not Hudson. Audrey is about to go on a trip, so I like to make sure that students have the ability to see what they missed in class. So if you don't see the red-white border while we're having class, just remind me, like, hey, Hudson, are you recording? Like, just throw that question at me. This is due by the end of today. If you have not turned it in yet, which I think a lot of us have turned it in, but if you have not turned it in yet, please do so by the end of extensions. Not right now, because we're about to start class. So you should have already done it during the, I don't know, 10 minutes that we've been in this room. If you haven't done it yet, do it at the end of class. Right? Don't do it right now, because we're about to start our lesson. All right, so this is a really long title. You could just write simplifying expressions. You want a header for your notes, you could just write simplifying expressions. Simplifying expressions. And that is one of those FYING situations. Simplify. Huh? I mean, you can, I don't care what your header really is. It's whatever makes sense to you. Did you make your header subtraction and non-division? All right, so for each of the expressions that we have up here, no, wait, expression. What's the difference between an expression and equation? What's the difference between an expression and equation? Xander?
An equation is like, it's an expression that contains an equal sign.
Yeah.
Expression is just expressing numbers.
Yeah, and actually more than that, it's not just an expression containing an equal sign, it's two expressions with an equal sign relating them. Right? Or we can have inequalities. What's an inequality? Yeah, where more specifically, not only do they not match, but we normally know which one is
greater and less.
What about when we use Yeah, somebody shouted it out. We know which one is bigger and which one is less. So part of what we're doing today is identifying which side is bigger, right? And what we're going to start getting into is with equations and or inequalities, if they do not come out to be equal, which side is bigger. So if somebody asked you, which is bigger, 58 or 62? You'd be like, duh, 58. No, I'm joking. So yeah, you'd be like, obviously 62 is bigger. Right, but if somebody asked you which is bigger, 2x plus 8 minus x minus 3, or 6 plus x plus 1? Well, this one has 7 and an x. This one
Has 5 in it.
has an x, but it has an 8 and a negative 3, so it's got 5. What's the issue with trying to compare these two expressions with each other right now? Patrick? Yeah, there's variables, and it's a variable because we don't know what it is. Right? So you can't really easily, I know, we'll get there. You cannot easily work with variables, but sometimes things work out, and we actually can. So why does this one work out?
What about me?
Yeah, you just said that, like this one.
Okay, so x plus 5 would be the 2x. Yeah. X plus 5 is less than 7 plus x.
X plus 7.
I mean, sorry, x, yeah.
Why? How do you know? So Alina said x plus 5 is less than x plus 7. Go ahead. Why do you know that?
Because x has to be the same thing because they're the same variable, and 5 is less than 7.
Even though we don't know what x is, I have the same thing I don't know on both sides. So this is more difficult to compare than 58 and 62. Like Lena said, we can because the x's are the same. Now here's where it would get tricky and like things don't necessarily work out if one side had like 2x and 5 and the other side just had 1x and 7. Now that doesn't work out. We aren't sure about that. We don't really know anymore because the x's aren't the same. So you don't have to understand all of that, but that's where we're headed with today's lesson. So, to back ourselves up a little bit,
Would it have to be equal or greater in that scenario?
we wouldn't actually know. It would depend on what x was. Remember, x could be positive, x could be negative, x could be 0. But you're saying if. Now you've put some constraints on it. We don't know anything about x. All right, build this on your algebra mat two different ways. 7x minus 3. Cough, cough, not subtraction.
Are you not adding on 3 tiles to your paper? Yeah, you are. Put tiles on your paper.
This is, I can't even make that very big. It gets grosser. The pixelatedness, that's grosser. It's, you know what I mean? It's really pixelated. Those aren't x's. Remember, x is different than x squared. X is different than x squared. Now, you do not have to use algebra tiles. If you think you're comfortable without using them, you don't have to use them. You don't have to get them all out. I never said you have to. I said a long time ago, with algebra tiles, it's up to you if you grab them or not. Now, I know that some of my announcements, go straight through and don't necessarily get processed.
I'll take a really, really hard bet that I was repeating during that announcement.
Mr. Hudson, did I do it right?
Ask Bear. That's why we're in partners.
Oh, my 855. Did I do it right, sir?
Check with your partner. Compare your expression mats.
I did it. Here, show me mine.
I like being slightly creative.
What do you think mine? Hey, that's not right.
So, just to follow up from yesterday, because I know some of you are still getting used to Phoenix and teachers and students being able to fight with each other, and that's okay. So Alina and I followed up after class, right? And we continued this conversation because I was exactly like Alina when I was in college and maybe in high school. I don't know if I was confident enough in high school. So I love your confidence to say no, this is what I feel, this is what I believe. But we kept going with this conversation of okay, what am I trying to get you to think? Right? So what I clarified was I wasn't saying at all that she was wrong. And I wasn't, she might have been saying that I was wrong, which is okay, because I'm often wrong. But what I was trying to get you guys to think about was in certain situations, we cannot take away. And when you got taught subtraction, you got taught that was synonymous with take away. And if I have 7x and I'm told take away 3, well, I don't know what 7x is. So I don't actually know if I can take away 3. So instead, when we use our expression mats to build these things, we actually add on 3 tiles, either positive tiles in the opposite land or negative tiles up in the true value area. And then I could have my 7x's together, or I could split them up by flipping as we cross the line.
It makes so much sense.
He's crawling under the desk in middle school.
That's fine. I don't care where people sit. So, that was how we followed up. Now, the other thing I said was it works the same as subtraction. So I'm trying to get your brain to go away from using that word, but the math works the same, right? Thought process is different, but the math works the same. Simon?
So when it's the negative number, well, when it's flipped in the true value thing, I view it as anything in the true value thing, I view as addition. But when I do it in opposite, I like to view more as subtraction.
Yeah, and that's totally fine. That's how you view it. But just remember, we're not taking away, right? We're saying this is the opposite of.
Well, that's why I don't like to have things in the opposite. So.
So Simon brings up a point. Do we have to have stuff down here in the opposite area? No. So when we have a situation like B where it says, hey, in the opposite area, we have a negative 2x and a positive 6. So in the opposite area, we have a negative, what is it? Negative 2x and positive 6. So I can move all those. Positive 6. And we have 3x in the positive. So Simon, if you said you don't want anything in the negative area, how do you fix that?
Should I go up and show, or?
I mean, if you come up here, you can't really go up to the smart board.
Yeah, I know, but
Here, we can make this bigger, and then I can walk away.
Is there audio on the cameras?
so
Yeah, it's recording from the
you would
mic
just
built in.
flip it once you switch sides. So you would flip this 1 over to a -1. You would flip this 5 over to a -5. But I just need to clarify that does not change the value. So I know we've already spoken about this, but this is the exact same as this. It's just in order to show it properly, you have to flip it once you get over here.
I like that you made that reminder. It does not change the value. It just changes how we look at things. Now, I like this a whole lot better. And now we could write it as subtraction, even though I deep down in my heart don't like that. We could write it as subtraction. We can now. Liam?
Well, I didn't really understand what you were saying, and then I did it with like the algebra tiles, because like I was putting 3 tiles on my paper, even if they were negative, I was still adding
Yeah,
tiles.
you're bringing it in, right?
I wasn't taking any tiles away, even though they were negative.
Yeah. So that's the point of us working with the manipulative, is hopefully that helps solidify the thought process we're trying to get you to. So now, when we start comparing expression mats, and we will get to a point where our expression mat gets cut straight down the middle, and we have a left side, right side, and we're told they are equal, and that's the beginning of us really digging into algebra. So if you heard your parents say, like, are you taking algebra or are you taking geometry? Algebra is where we're getting into with variables and constants and all these things. Yeah.
My dad's been trying to get me to solve for x since like 3rd grade. Like, what you gotta do on one side, you have to do the other.
Just tell him his X is not coming back. No, that's one of those funny math shirts. Like, quit asking us to find your X, it's not coming back.
No,
Yeah.
there's this note, like there's this Instagram post.
Oh, Insta.
My friend like gave it to me. It was like, dear X, please stop letting me solve something. And then like she's never coming back.
Yeah. And I forget what the other one, like the other joke is. Oh, by the way, sorry, the reminder I need to make here. Remember that with negative numbers, the bigger the negative, the less the value is. So when we look at comparing -3 versus -2, what you're asking yourself, and this is kind of covered up with my new screen that they put up, and let's just do this. I should move it somewhere else. The bigger the value is, the higher up it is. And I know that we've taught you for a long time, like number lines go like this, but really, when you think of a number line, you want to think of it vertically. So when I compare -3 to -2, -2 is bigger, quote unquote, even though 3 is more powerful, -2 is bigger, or has a higher value. That's why I don't like saying bigger, smaller, has a higher value. Yeah.
I already beat my algebra game.
You already beat your algebra game? What was your algebra game?
Dragon Fox.
Oh, nice. I don't know what you're talking about, but now I'm curious. All right, so
Look it up.
if this is your mat, and we can actually, I will allow people to come up and help me with this, but after you do it on your own. So, again, because apparently some people missed this announcement when I made it like a few days, like probably a couple weeks ago, algebra tiles are your option. Okay, if you decide I'm done with the manipulatives, I don't want to use them anymore, you don't have to keep using them, but you do have to engage in the math that we're all doing together. Yeah. So if this is one algebra mat, or sorry, right now we're just calling them expression mats, and this is another expression mat, which one of them has a greater value? So either work it on your mat or write some things down if you want. I need you to be able to tell me the simplified value of both, and then which one is greater. So that is this mat right here, I just copied it so we could have it bigger. Which one has a greater value? So take a minute.
It's neither one.
Oh, no, you're right. Never mind.
So we'll do this one together to make sure that we're all comfortable with what we're doing. I'm going to show you one where we can move the tiles. The first thing in your head. First thing. First thing.
Okay.
Do you know?
I know which one's further.
Oh, but I don't want the answer yet. The first thing we think about.
You write down the entire expression.
Yeah, if we're going to write it down, yeah, but if I'm doing it on the mat. I totally agree with you, but if I'm right. We what?
You have to put every single tile down there.
Yeah, we would put them on the paper, but then I can do something to make things easy right off the bat. Ooh! I can either follow the signing technique and put everything on the positive side, or I can make zeros, and then I would still do the signing technique of put everything on the positive side. So we could make zeros anytime we see opposite quantities, right? Those are opposite quantities, so really gone and gone. Opposite quantities, gone and gone. So now when I bring these up, remember these will flip when they come over. So to give you the better visual representation of that, check it. This is what it would look like to start. Every pair cancels out and becomes zero, so those those come out. These make a zero, and those come out. These come. What happens when I come across this line? Flip it. So come across, come across. And then over here we said we can merge these and make a zero, so that comes out. Merge these to make a zero, so those come out. And then, ooh, so when I do that, there's another zero. That can come out. This. So am I able to compare these two mats?
Yes.
Yes. Why? I should use cards to see if people are paying attention.
I know, I was about to say you.
I'm convinced my card isn't in there.
You're
I'm
convinced?
convinced my card isn't either.
I gotta check if I'm on the right class. That's math 7.
Definitely in there. I know.
I've been big on it. My card is in.
Yes.
Remove a one on the right and a negative one on the left.
The one on the right. How? How would I be allowed to do that?
Cancel out. So
Because they would cancel out.
But they're not on the same mat.
yes, but it'd still be the same. It's still
No,
Wait, can I show something that does cancel out?
So hold up. I like what you said, but let's talk about where this isn't allowed to happen.
It's because it's
Hey,
not one full
Yes,
equation.
but stop. Yes, but stop. Put those back. We can wait. Nobody asked if they could come up. Nobody invited you up. You're just taking liberties. So Logan asked me to remove a 1 tile from the one mat and a negative 1 tile from the other mat. Right now, all we've done is make zeros and move across the middle line. Right? If I take 1 away from here, that's like literally like taking $1, right? Or taking a candy bar or 1 of something. If I take a negative 1 off here, that's like removing debt from somebody. Those would be opposite actions. And I can't do opposite actions. Then things aren't fair anymore. So what I am allowed to do is the same thing on both sides, which would be get rid of that x and get rid of that x, because nobody likes their x. And actually, I'm still friends with my x's. Then I have negative 3 compared to 1, and now I can compare these. But I can't do different things on the 2 sides. Simon?
If you don't want to compare with negatives, you can just add 3.
Ooh. So if I add 3 algebra, could I put 3 algebra tiles over here and 3 algebra tiles over here?
No.
I can do whatever.
You have to
Yes, I
put-
could. I could just drop them, right? is my one mat still fair with the other one? Did I do the same stuff?
Yeah.
Yeah, if I add 3 to both. So what Simon's saying is if I add 3, that would wipe these out, and then this would become 4. Right? So then it would be comparing 0 to 4. I can still compare those. So, on your own, because we worked through that one together.
I feel like my head's hurting.
Good. That means you're learning.
No, it doesn't. Sometimes
We want to help
Wait, Brandon, we threw this right then?
Carl.
Yes.
Carl. Carl.
Isn't this in the homework?
Yes, this is on your homework paper.
Oh, I already finished.
So look at
Boom.
your salmon sheet. If I can ever pick it up. Look at your salmon sheet right here.
Those are all the answers.
Wait, super card.
So Carl has this set up. What we've been asked to do
Yeah, Carl.
to explain in writing what he did to each expression comparison mat. So really, what I'm going to ask you to do is write out what he had originally and then what it turned into. So for example, let's say A. When he started, he had 4 filled in, 3 not filled in.
4x
Right?
plus.
Not X.
Oh, no, you're right.
The
4.
constants, right? 4
4 plus negative 3.
4 plus a negative 3. And then over here,
That changes.
he had 1 plus a negative 3.
Ooh, I bet I know.
I
who's
understand.
What it ends up with is 1 and negative 2. Because, well, when I do that math, yeah, that's what we get. So you want to do that to write it out for B and C. You don't have to do A. We'll go ahead and just let you do B and C.
So, like, what it is or what he did?
So really C is where we're going to start talking about the algebra. So look at what happens in C. We've already kind of talked about that because I overteach. I get the stuff before the book gets to it.
Well, that means you're a smarty pants.
That means you guys are smarty pants. So for C,
We're smarty pants.
B is pretty easy. Let's go ahead and get to C because I kind of want to show you guys a little clip before the end of class. C starts with x plus 1 plus negative 2.
I can simplify it.
Right? On the left side. The right side, x plus 2 plus negative 2. Then, what they show us. What did they do to both mats? They took out x from both of the mats. So, we could show this with minus x minus x. And as long as we do it on both sides, we keep it balanced. There. I don't care. I don't know what you're about to do, but
You just
whatever.
gotta simplify the right more.
Okay, so take that out, take that out, take these out.
You could do that over
I
over
took one.
do it over there. Do it on that one. Yeah, circle the zeros.
Can we simplify that?
No, you can't do that. You can't circle things on 2 different. Now, okay, are you saying remove those because they're the same?
Yep.
Because it depends on how you phrase
It
it.
just makes it 1 and 0.
So Bear's got a really good point
What
here.
about subtracting them?
We were just thinking 2 different things. So I thought,
Subtracting.
hold up, I thought Bear wanted to make zeros. That isn't actually what he wanted. But what you want to show, you need to show a different way. If Bear wants to show remove the same thing from both sides, how he would do that is circle the thing we want to remove, show it leaving. Do the same thing over here.
And then the negatives.
And then the negatives,
You can
and I'm going to use a different color.
1v0.
1v0. Makes it be on the side, like.
So now, left mat, nothing, everything's gone. Right mat is 1. Yeah.
I've noticed that you disagree with some of the ways that we were talking about. Do you disagree about like the greater than sign when they're like eating the bigger number, the alligator?
No, I kind of like that technique of saying, you know, an animal would turn towards the larger quantity.
Okay, I was just wondering.
Yeah.
I'm so confused when instead of like doing it that way and you cancel and you just make zeros, then like it comes out to be a different answer.
It does not come out to be a different answer. Shouldn't.
Ooh.
So So hold on, let's see if I have another example here. All right, so Carl
Yeah, Carl.
Carl is allowed to make legal moves. For the sake of time, let's go ahead and look at B. Because I can extend the page and write in the bottom. So this is 49B. Right, you had 48 on your pink page. Work with me here, because I'm going to show you the algebra. I'm going to show you the algebra, so please work with me here.
Should we take away the x's first?
Not first. First thing we're going to do is write everything down. So we have an x. Hey, Bear. Chill out. Plus 4. Plus a negative 2. And we'll go ahead and say minus, although it's a little weird. I have a 2 down there and a negative 1 down there.
Whoa, fancy!
Nested parentheses. If you've never seen that, they're just called nested parentheses.
I've seen it.
I've done it before. I've done it with like 4 nested parentheses.
X. If you're not working with me, that's your choice, and you will have to live with that. And you don't know what we're doing. That's a plus, negative 2. And then in the opposite world,
Negative, negative, negative.
the opposite
I
of
see. So you have to, like...
So while I disagree with how I wrote this, it is the exact... What? It is the exact iteration of what they showed me. It is the exact iteration of, I'll agree with you today, actually. I did. So now, if I go to clean stuff up.
X plus 3.
Opposite. Opposite. Because I don't like subtraction. X plus 4.
It's much easier than 4 plus
Negative 2.
No, it's not. Are you crazy?
Wait,
Negative 2.
this is a type 2 claim, okay?
It's just fun.
See, I feel like solving it on the expression map is way easier than doing it on the equation. Because that means beat in my head hurt more. I don't know what happened with the negative 1. Oh, there it is. I found it.
All I did there is get rid of subtractions. Right? I did the anti-Alina and I got rid of all my subtractions.
I want to do something.
Now, I know I'm taking so long that some of you, like, your head is exploding. Now I group like values, not even like terms. Stop. Some of the behaviors in here are more childish than any classes I've ever taught, and yet you're supposed to supposedly be the smartest.
Albert Einstein was childish and he was stupid.
Looking at me and then looking at Helen.
I didn't know Albert Einstein was a girl.
When I go through, I get my positives together and my negatives together. So I have 5 positives, 4 negatives, and well, what's a positive 5 and a negative 4 going to simplify out to? A 1. And over here, my positives, well, positive 1, positive 4, so x plus 5 plus negative 2.
I'm having trouble. X plus 3.
We're writing this out in the longest way possible. I'm not joking. Like, this is literally the longest
Now,
process that we could take.
Take out the x's and include that 3 is bigger than 1.
Here's where I need you guys to start really paying attention. Because you don't have to do this yet, but like a month from now you will need to, and if you can train yourself now, you'll save your like reteaching later. When we start to do things on both sides, I have not done anything on both sides. I've just simplified, 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 simplified. But now I want to do an action to both of them and make sure that it's fair. Anytime I do that up here, my goal is to write it in red, because that's something I'm doing in both sides. That's like a critical color. So Liam's been begging me, just get rid of that x. Just get it out of there. So I subtract x on both sides. This is happening on both sides. This is the algebraic property of equality. And you don't need to know that yet, but all that means is if you do it on both sides, it's good. So now we get left with.
Wait, isn't that just? Wait, can I say something?
Yeah, sure. Go ahead.
Isn't you can? Oh, never mind.
And if we compare 1 versus 3, what symbol should go in the middle?
One. With that.
You can even take away one from each of the sides.
We could take away 1 from each of the sides. But we already know the right one's greater.
Okay, but if
Yeah.
So, the way you just wrote versus made me think of something I've never thought about before. What does the V and the S stand for?
Like the letters versus, like that it starts with a V and ends with an S.
Yeah. Versus.
Like literally, like VERSES, like that is like competing against.
My brother used to.
All right, to help you with this idea of algebra, please start putting your tiles back in the bags, but do not go anywhere yet.